Good morning, good afternoon. Thank you for joining us today for today's Tech Talk. Today, Aran and I are joined by Aric Day, Solution Architect, who's going to be educating us on OAuth and OpenID Connect. But before we get there, first of all, yes, we are talking. If you can't hear us, you don't know that, but you do need to connect to either your computer or your telephone audio. The easiest way to do that is locate the audio tab, select telephone, dial in using the information provided. Once connected, enter your audio PIN to identify your line, and at that point you are successfully connected to audio. If you drop for any reason, simply re-log in. Use your control panel. You can expand and collapse your panel. This is useful if you're on a tablet or a phone while watching this. If you want to expand it, you merely click the orange arrow pointing to the left, and to collapse it, click the orange arrow pointing to the right. Again, you can view and select your audio on this tab. And most importantly, if you do have a question or comment during the session, by all means, please enter it here. We will get to them at the end. And everybody is on mute because this is being recorded. And with that, let me jump into an announcement I made about maybe 10 minutes ago. API Academy, you guys know us as the premier resource for API strategy and design. And what we've decided to do is expand upon that with a new certification program that just rolled out a few minutes ago. It will have multiple components. API Academy Certified API Designer, that is available today. API Academy Certified API Security Architect, that'll be available in June, and then Certified API Product Manager will be available in late summer. What this is basically an independent education and certification program for API strategy and design. It is the first agnostic program available at no charge. It is personalized, it's self-paced for API designers, security architects, and product managers. And what we're focusing on is delivering proven best practices on demand. Each course completion delivers a certificate and a badge, as you see on the screen. What we encourage you to do is after you complete the exam, by all means, share your certificate online on LinkedIn on the API Academy group page. We'd love to see your certificate there. If you complete all 3 courses and pass all 3 exams, you get another badge, which is API Academy Certified. Other recent enhancements to the website are new how-tos. Aran in particular, his team has been focused on resolving common how do I blank. And what we're doing is a combination of blogs and videos, very short videos, to show you exactly how you accomplish that how do I blank. It answers frequently asked questions and demonstrates best practices for common tasks. We also have a regular cadence of contributions by industry thought leaders, both internal and external. And we are offering complimentary virtual and worldwide in-person training via workshops. We originally planned, we are a global sponsor for API Days. There is some news there that just came out yesterday. They are going virtual this year, so we have to kind of figure out how we're going to handle that. But the plan is to do API Academy workshops in place in the cities you see on the screen. And here's a quick snapshot of when you log into the API Academy, you'll see your dashboard, which shows you your courses that you're enrolled in and allows you to start, in this case, this particular screen, nobody has started anything yet, but you can start a module and walk away from it, come back, and it'll be left off exactly where you left off at. If you finish one of the exams, again, you can stop halfway through and come back later, so you don't have to worry about losing anything as you go. Next month's Tech Talk will be May 20th. It will not be the last Wednesday of the month because the last Wednesday of the month for US involves Memorial Day, which tends to be kind of a slow week. So we're moving it up to May 20th, and Aran and I will be hosting Dmitry Sotnikov, the CPO of 42 Crunch, and it'll be a panel discussion on API security. For those of you who don't know Dmitry, by all means, you should go sign up for his weekly newsletter. He details the latest breaches in API security around the world. And with that, I'm going to turn it over to Aric Day, who's going to be talking to us about OAuth and OpenID Connect. Give me 1 second here. And Take it away, Aric.
Thanks, Bill. Can you hear me?
Yes, we can.
Excellent. All right. Hi, everybody. Thanks for joining. My name's Aric Day. I'm a pre-sales consultant. I'm based out of Minneapolis, Minnesota. Today, as Bill said, how do we, blank? Today's how do we topic is going to be OAuth 2.0 and our OpenID Connect implementation using the Layer 7 API Management Gateway. This is very specific on our business unit and within Layer 7. I know that within Broadcom and CA solutions, there are other products that provide OAuth capabilities. Today, I'm really focused on the Layer 7, what we call our OAuth Toolkit, which is deployed as an additional component on top of our running API gateway that has some additional components installed and configured. So at a high level, within the Layer 7 API management family, we're going to be really focused in on double-clicking on this OAuth Toolkit in the middle. Here I'm showing it as independent and disparate from an API gateway or a containerized gateway. All I'm indicating here is that this can be both an authorization server, your token provider, as well as integrating with your resource server to do validations. In the demo today, the OAuth Toolkit is going to be installed right on top of the API gateway, and the data store is going to be co-located with the admin repository. We'll take a look at the different types of data stores that we can use for our OAuth Toolkit. MySQL obviously comes with the gateway appliance and is familiar with gateway administrators, but we do recommend additional data stores like Oracle or a non-relational data store like Cassandra to get the maximum throughput when you're talking about really high request response OAuth implementations. In addition to this, some of the other tools that we're integrating within the DevOps or digital BizOps unit within Broadcom is our API testing solutions, and you'll see those in this gray box up here. And so whether or not it's automating the creation of OAuth clients and possibly registering through an OpenID Connect dynamic registration through CD tooling, or whether or not you are trying to test an API that is integrated and protected with OAuth, your monitoring solutions and your testing solutions will have to be aware of and be able to integrate with that OAuth Toolkit in order to give you the full testing spectrum, to test your security as well as the functional capabilities of the gateway. So with that context, we're going to really click in on the OAuth Toolkit, talk about what it is, what it provides you out of the box. So really the installation, the configuration, customization, and then some automation of our OpenID Connect implementation. But we'll start with just an overview of OAuth. It started more than 10 years ago. OAuth 1.0 is largely deprecated, although there are some major vendors that I see still using an OAuth base signature, including some of or at least one of the big four credit cards. But by and large, most of the clients that I interact with have moved on to OAuth 2 framework, and OAuth 1 is largely deprecated in enterprises that I've seen. And on top of OAuth 2, which provides an authorization capability or a delegated authorization to applications on behalf of resource owners, we also have OpenID Connect, which layers on top of that and provides a authentication capability on top of the authorization. All right. The major components, and all of these are available out of the box using our test client and our default OAuth Toolkit implementation. But we have the resource owner, and that is the end user or the ownership of the data assets that are going to be being served. And the resource owner interacts with the client. The client has the representation with the OAuth Toolkit and is represented by a unique client ID. Often in the handshake, the client ID also has a client secret that is used in exchange for an OAuth token and one of the various grant types. The authorization server is your security token service, and that does the issuance of the OAuth tokens. And then your resource server validates the OAuth token that is presented and interacts with the token server, validate the incoming request, and then provide and expose the data on behalf of the resource owner to the client. And I think it's a point of confusion, but also a point that I really want to make clear is that OAuth 2 is really delegation of an authorization to an application, not necessarily to an end resource owner. OpenID Connect starts to bring in the identity of that resource owner into the client. We'll talk about that in a moment. What you see on the screen here are some of the grant types and extensions that are provided in just the OAuth 2.0 standard RFC, as well as some extension grant types that are very popular and that we often see being requested by our clients and that are implemented out of the box with our solution, except for the very last one you see here. This is a newer standard. This RFC, it was proposed just this year in January 2020. It's been going through a lot of increments, but I really think it's interesting. It takes OpenID Connect and the idea of tokens injected within tokens or scopes of scopes. So you have token endpoints issuing additional JSON tokens and nesting them in one another. So you can have subclaims and subscopes of issued JSON web tokens, and allows for in-depth service-to-service authorization. So not something that we provide out of the box, but certainly OAuth 2 and OpenID Connect are becoming, I think, the de facto standard in most web authorization lightweight protocols. And OAuth Token Exchange and some large enterprises I'm certainly seeing with some uptake. All right. Standard authorization code grant type is considered the most secure. So I'll talk through that as you can see in the web sequence diagram here. Really starts with the resource owner making the access request. With an authorization call, the authorization server presents the client with direct input. And as long as the authorization server it validates, it will redirect the client with an authorization code. And the authorization code with the client's ID is then used in exchange for an OAuth 2 bearer access token. Once the access token and a refresh token has been issued, then the client has a closed loop to send in the access token until it is expired. Once it's expired, if the refresh token is still active within an authorization code grant type, that refresh token can be submitted for a fresh token. Some of the things we'll look at today are customizing what type of access token is returned. We'll also look at the token lifetime management and how to customize some of those settings when we're installing our OAuth toolkit. So some of the advantages are you can decide what type of token you want to issue as an access token. You can either have just a bare opaque token or a UUID token, which needs to then be validated as an opaque token. You can't inspect it and look at it. Rather, you have to send it in to a validation endpoint for certification, versus a JSON web token, which can be self-validated, can be signed, can be encrypted, and can be used for further assurances. Within OAuth 2, we can also use asymmetric or symmetric cryptography to generate the access token. So whether it's a shared secret or PKI encryption, and then the exchange obviously can be over HTTPS, and that TLS or SSL tunnel can be encrypted and then further authorized through mutual TLS. I mentioned a little bit of the claims and scopes that are naturally part of OAuth 2, and as we get into JSON web token and OpenID Connect issuance, we'll start to get into OpenID claims, which further allow things like access, read, and write, and access to some personal information, be it an email or telephone of the end user. And then those claims can further be used downstream for additional processing or sub-authorization as we get more granular within services. One of the capabilities that adds some additional assurance in the authorization code flow is the ability for a client to register a secret so that it follows what's called a proof key for code exchange, so that as the client is exchanging what we saw as the authorization code for an OAuth token, they also send in an additional unique identifier, which is then validated at the token endpoint before the token is returned. It just provides an additional level of assurance and protection. And this is not required any additional configuration within the OAuth toolkit, as long as you follow the spec and send in the proof key, it will be validated. So session management, the ability to, within the CA's OAuth toolkit customization, be able to go in and really customize how long caching happens within an OAuth token, especially if you have a UUID or an opaque access token, how long will the validation of that token last? Is it a one-time use access token only, or will it, persist for 30 seconds, 60 seconds? And then the load on your system also is highly dependent on, whether or not you're using a chatty protocol like UUID, and for every validation, if it's a one-time use token, that's a lot of extra HTTP calls. When you get into thousands, tens of thousands of transactions per second, those additional seconds of caching that OAuth token can really make a big effect. Or if you're deciding in your OAuth design, do I want to use a JSON web token and do signature validation, or do I want to use a UUID, keeping in mind the CPU and the resource constraints that would happen if you're trying to execute signature validations on 10,000 JSON web tokens per second, the load on your system is going to be very different than if you're validating a UUID that's setting cache. So some of those considerations certainly need to be at least in your mind as you're starting to develop the standards for how you'd like to customize and implement your OAuth toolkit. Our default settings are very performant. So for example, and I'll walk through this, but we use the UUID access token by default, but being able to flip that switch, use a JSON web token instead of a UUID is a very simple configuration. So we'll take a look at that. One of the things I'm not going to look into a whole lot is the customization and call outs to other systems, whether or not it's an other authorization server or another token provider. We do provide an all-in-one solution. Of course, it can be customized to call out to other systems and exchange tokens. But for the purposes of this demo, we'll look a little bit at some customizations regarding social login, some of the abilities we have there to add additional grant types and flows based on social login. But we will not in this demo dive into that too deeply. OAuth is really based on open standards and really tries to achieve maximum interoperability. The fact that I think it's focused on that is really shown in its adoption and uptake in the industry. All right, so the deployment of our OAuth toolkit really follows deploying and managing functional components. So if we think about an authorization server, this is going to be tied in with your identity management system versus token server, which will generate and issue, validate, and store the underlying access tokens. Resource server, in the end, serves up the backend protected resource. These are the endpoints or the APIs that you would find typically in the DMZ. These would be accessed only by HTTP, can be further restricted by TLS, and would be externally exposed. This would be in a segmented architecture. Of course, all of these components could be deployed, on one server, either in the DMZ or internal. This is a more complex implementation where your risk surfaces are limited and you're only exposing to the DMZ API HTTP endpoints. As we get back into your data tier, where your clients' sessions exist, including client IDs, tokens, when they're generated and stored, any session information about the underlying user or custom attributes about that OAuth session, those are stored in the underlying data store. I mentioned we offer a few different options for that, but this could be your MySQL token store, your Oracle, or your Cassandra. Now, these are going to be accessed, via JDBC calls or data access calls, not by HTTP APIs necessarily. And so the risk surface on accessing these data elements is a little bit more risky. And as we think about a reference implementation, if you have a segmented architecture where you're exposing something in the DMZ and something internal, obviously your data stores and those, JDBC calls or system-to-system calls to your token store, your identity providers, you want to maintain protected in a trusted network as best you can. The implementation of our OAuth toolkit allows you to chunk out individual components in the boxes you see here and deploy them segmented within your architecture. This just summarizes what I just said. If we talk about a client making a sample request, I'd just like to level set on the process and the individual services that are invoked. So on the first authorization request, the client interacts with the authorization server. Obviously, the authorization server will collect the credentials, validate the client that's sending in the user's credentials. If it's a three-legged, where the end user actually enters in their username password. The assuming that the authorization server validates the client, token is validated and returned. Subsequently, the client will make a token request that will access the token server, and we will validate at the OAuth validation point that the client is valid, that the token is not expired, and that the session hasn't been revoked. Once that's been issued, the token has been validated. Oops, sorry. The resource server is accessed by the client with the access token. The OAuth validation point validates the token on subsequent calls and then returns to the backend server the data that the client is looking for. At this point, you see the validation point making a call to the token store. In a one-time or a no cache scenario where it's validated each time, this call would happen, in a synchronous mode. You can imagine that, tens, hundreds of transactions all calling in with the same bearer token, that this could become very chatty, especially with lots of threads happening at the same time. So the ability to cache that OAuth token and manage the session without making synchronous calls is really important at high volumes. All right, so that's the architecture, the components that we're going to take a look at installing. As we go through the installation, there is some setup, and obviously the first decision you have to make is, where am I going to store my OAuth tokens? Are they going to be located on just a single gateway and only known to that gateway? Or will they be located within a cluster of gateways? Or will they be a disparate OAuth implementation that's integrated with many gateways, all feeding off the same OAuth toolkit? So whether or not you want an OAuth token that's generated in one geography to be accepted and recognized in another geography starts to get into, the writing into your data store and the replication of that data store, the latency of that replication, and just how wide of a network or how wide of a geography you want to make that OAuth token available. For the demo here, we're just going to do a very simple single database node with one gateway feeding off of it. The first activity is we'll have to download some scripts, some installation files from the CA support, depending on the data storage system that we're going to use. We'll create the schema. Then we'll go into the policy manager. We will integrate our data source into the policy manager as a data connector, so that we identify where our token store is. And then we'll go through the installation of the DMZ and the internal components that we saw. Once we've done that, we'll take a look at some of the first configurations you'll want to make in order to get the test client working and to establish trust. And we'll also take a look at identifying user authentication and various grant types within our OAuth toolkit. All right, to get started, you click on the TechTalk link. This brings us out to the OAuth Toolkit 4.4, which is the most recent release. You've got the download site here. We can download the latest version of OAuth Toolkit 4.4. From the download site, it'll be packaged as a signed solution kit archive, also known as a SCAR file. These are applied through the policy manager. So the installation is going to be a two-step process where we go through the process of database creation. So we decide whether or not MySQL, Oracle, or Cassandra is appropriate. For each of the data storage subsystems, there's a schema file. There's also a sample test data file. So in order to utilize the test client that we'll see today, we'll have to populate a sample OAuth client. That's contained here in this test data. In a production system, for example, maybe you wouldn't want unauthorized clients, or not maybe, you wouldn't likely want just a random client present. So this test data file is not necessary, but it's sure convenient as you're deploying and first understanding the OAuth toolkit. But the schema is really all you need to instantiate the database and to enable the connection. All right. Not every one is going to be installing from scratch. Maybe you have an older version of the OAuth toolkit. So we also have upgrade files here going from previous versions to upper versions. All right. Those are all available here. Once you've got those downloaded and you've got a data source that's been instantiated with the schema, then we can simply drop into the policy manager and go through the installation. This should look familiar if you're familiar with layer 7. To get started, we go down to extensions and add-ons. Here we can see the managed solution kits, which is where we'll upload that signed solution kit archive. But before we can do that, we have to establish that connection to the data source, be it Cassandra or Oracle or MySQL. So in data sources, you'll notice that I have a connection named OAuth. So within the signed solution kit, it presumes that there is a connection named OAuth. So if you don't have this particular connection name, there's a resolution that you'll have to go through and click on the name of this entity that you create. But here you will enter in the driver. In this case, I'm using MySQL, your JDBC URL. And in this case, on this MySQL server, I created a database called OTKDB, and I provisioned access for OTK user. All right, so that's the simple configuration. I have a new MySQL database. This database has been initialized with that MySQL schema we just looked at. I can test it from here, validate that the JDBC connection is working, and hit OK. If you choose to use Cassandra, which is the non-default data provider, so there's just a little bit of additional configuration you have to do, but you'd simply drop into manage Cassandra connections and add those here. All right. Once you have your data source established, go back into manage solution kits, and you can see I have already installed my OAuth solution kit. And I'm just going to drop into properties. In the interest of time, I had this installed. So what you'll notice is just the sheer number of components that get installed. And so we have shared resources for both DMZ and internal components. You'll notice that I have 2 persistence layers configured here. So I did create 2 data sources, one Cassandra, one MySQL, just to show you both. But when you're installing the portal, you don't need to select both. You can select either MySQL portal persistence or Cassandra. The MySQL is the default configuration. So as long as you enter in a MySQL endpoint, there is no additional configuration you need to make. It's only if you choose to use Cassandra, there is some additional activity. The other components you'll see here are the internal. So those are the internal server components. And just the sheer number of entities. So everything you see here was installed. We've got the creation time and then the version of the OAuth toolkit shown here. You'll notice that my OAuth toolkit, I don't have any instance modifiers. So our toolkit does support multiple, installations, as long as it does have a unique resolution path within the gateway. So if I wanted to, for example, install another OAuth toolkit that had completely different attributes, maybe the authorization page was very different, token lifetimes were going to be configured differently, or the default token type that was issued, that could simply be installed as an additional solution kit with an additional instance modifier. Okay? The installation of this, to go through each of those objects that we just saw, takes probably between 5 and 10 minutes, and you just have to resolve the data source named OAuth that we took a look at in the JDBC. Once that's installed, what will happen is in the lower left-hand policy pane, you'll see a brand new folder created called OTK. All right. Now, one of the first few things you're going to want to do once the OAuth toolkit is installed is be able to access and call it with users that you're familiar with. So within our solution, under identity providers, the default identity provider is called our internal identity provider. All right. So if you have users that you'd like to use against the OAuth toolkit in your internal identity provider, that is configured as the default, which is just fine. Most enterprises will want to hook this into their enterprise LDAP or single sign-on solution. And we can do that under what we call our customizations folder. So within our OAuth toolkit, we have our server capabilities, which show the DMZ and the internal components. And then we have the core policy fragments, or the core functionality, the inner workings of the OAuth toolkit. These policy fragments, by and large, are all going to be all read-only. This is the black box or the spaghetti bowl of functionality that you don't really need to be concerned with, especially as you're customizing and configuring your OAuth toolkit. We've really confined those capabilities to the customization folder. And within here, you'll see hash policies. So that hash policies are basically subsets of the parent read-only policies, and this is where your customizations occur. So if I wanted to customize our user authentication extension and not use that internal identity provider, I can simply click into that. This is the default setup you'll see here. So this is version 1 of 1. And within this branch, you'll see this is where we do our authorization. Now, within this branch, if I had a corporate LDAP or some type of other identity provider, I would simply change the identity provider to one that I preferred. If I wanted to do multiple, maybe I wanted to check the internal identity provider, but if they weren't here, then check the corporate. I could simply do additional branches here. So within at least one must be true folder, I could evaluate the internal identity provider, this identity provider, that identity provider. All right, so that's the default setting. Obviously, we also have integration with our deeper security solutions, including SiteMinder, which many of our customers do employ. And for a long time, SiteMinder didn't have OAuth or OpenID Connect capabilities. They do now in a lightweight fashion. And security organization also has other authorization solutions. But if you're using the API gateway and you'd like to marry and pair the OAuth access token that's being issued or the OpenID Connect JSON Web Token with an underlying SM session, on line 16, you can see where that integration is made possible. So if I wanted to enable SiteMinder, there's a couple things I'd want to do. First thing, I want to come into users and authentication. I want to set up my SSO configuration. So just make sure you've got the appropriate agent and that you can communicate back with your policy server. Then you would simply enable this block here. All right. In doing so, you'll be able to exchange and validate against your single sign-on server and retrieve SM session attributes, including SM context, some of the attributes that you see here. And in those cases, you would likely disable internal identity provider, or at least make it a branch if they're not in SiteMinder, that then check here locally. All right, so that is configured and fairly easy on initial setup, and we try to make it, I guess, as out of the box user-friendly as possible by just integrating with an internal identity provider shown there. All right. One of the other customizations that you'll want to take a look at, or most will, is this OAuth Toolkit lifetime configuration. So here's a hash policy that was empty. I added a couple variables to it, but the question is, where are the others? What kind of options do we have? So instead of using the underlying hash policy, you can look at the non-hash policy or the read-only policy. And here we can see all of the defaults that are set for this particular OAuth implementation. The auth code is set here as 300 seconds. Access token, refresh token lifetimes are set here. So you can see the default, if I show numbers, the default OAuth 2 access tokens lifetime is 1 hour. And the refresh token lifetime is shown there. We also have a customized setting for our mobile client IDs issued via registration with MAG to a week. And any additional customizations you want to make, as you can see them here, the read-only policy would then pick up any additional customizations from the hash policy. So in my case, I might want to customize the lifetime of that mobile issued SDK client ID from 7 days to something else. So I can simply drop it in here and change this value to whatever's applicable. Likewise for changing it from 1 hour to some different value. All right. Now this would happen on the global setting. So for that OAuth toolkit that had that particular prefix identifier, this would be the default setting. For every client that is registered, there's also the ability to pass in and customize on a per client setting, but this would be at your global level and be able to set it for everybody in this particular cluster. Okay. All right, user authentication and the token lifetime. Now, I mentioned this a little bit earlier when validating versus issuing the token and the types of operations on the UUID that are different from the JSON Web Token. I want to call this out because this is something that's very important to understand as well. Token creation and token validation are very different as far as resource consumption on your gateway. Token creation is expensive. Token validation can be very cheap and very easy, especially if it's a UUID and it's cached, or even if the JSON web token is validating a signature. However, the token creation and the more, I guess, operations you run on the token, with a signature or encryption or additional value validations, those are all non-zero expenses in terms of latency and CPU. The other thing to think about is with our data storage subsystem, we have to synchronously write to the backend storage. What that does is allows for availability. It also allows for revocation. So by writing synchronously to a backend storage, if it's ever revoked, we can actually take it out of there. And when subsequent checks happen, the revocation will show that the token has been removed. When we deploy, instead of a UUID, and write that into the data storage subsystem, if we issue the JSON web token and we disable authorization storage checking, and I'll talk about this flow in a little bit when we look at UUID, the JSON web token doesn't write to the backend storage. It'll just validate the signature, but in doing so, you don't get revocation checking. So in those cases, if you don't have that synchronously written storage on the backend to check whether or not it's there, and you just are validating the signature of a JSON web token and maybe the expired at time, you won't know if it's subsequently been revoked since issuance. Okay. So that's just something to consider. We have, some enterprises that say, I just want to issue JSON web tokens. Once they're issued, I'll validate them and I'll validate the signature. I don't care about validating whether or not the UUID that issued it is still in your backend data store. But in doing so, and that's fine, you may gain performance in doing so, but you lose some advantages of revocation. Right. So in those cases where you've got really high throughput and you also want to do the storage on the backend, looking at a solid state disk or moving to something like Cassandra, right, which is sharded and non-relational storage subsystem, becomes much more preferred. We've actually seen, I have a large retail client here locally that's actually moved beyond this altogether. They asynchronously write onto a Kafka queue and then do their own validations on that asynchronous queue further down the stream, but they're certainly at the bleeding edge of capabilities of OAuth and OpenID Connect and most, but certainly things to consider as you get up in volume. All right, so let's take a look at our test client that gets installed automatically. Once you've deployed the OAuth Toolkit, this endpoint, assuming you installed the test clients component of the OAuth Toolkit, these will all be available. And just in general, when a new client application comes on and wants to start consuming OAuth, that developer must register the application with the service. Has to have some basic information. What's the web, what's the contact information? Do you have a redirect URL? Is it going to be a confidential or a public credential? Right? How secure is it going to be? Well, our OAuth Toolkit obviously has an interface called OAuth Manager that you can go in and edit that. We also have the ability to dynamically register clients and input this information as well. All right, so let's take a look at the client first. All right, we can get out of this, get out of that. All right, so in my instance, I've got my gateway installed at GW2.10. So I can see that I'm hitting my host gateway on my HTTPS port, and the resolution path for our test client is OAuth/d2/client/authcode. What we have here are all those extensions and grant types that we took a look at the beginning of the presentation. I have authorization code, implicit, resource owner, client credential, and SAML. Now, these actually just have endpoints on the gateway in which the test client submits these various requests. So depending on the grant type you're interested in, going into the underlying service located here and seeing how the flow is orchestrated in policy, I think is very insightful. All right. And before I configure any callback URLs, I could start with like a resource owner credential or a client credential. I don't need a callback URL for those to work. So if I click on client credentials, I'll initiate a two-legged OAuth handshake. I don't need to enter any end user information. This is just two-legged, and so the client is sending in their client credentials to the token server and is getting an access token in return. This access token, once it's been presented, I can simply turn around and click Call API from my test client, and what it'll do is send this sample access token to this sample endpoint, which is also available on my gateway. So if I go into Protected API quickly, let's hit Call it. What you can see is the access token has been validated. I see the client ID, and I see my subscriber ID. Now, in this case, the subscriber ID is this OAuth 2 client. It's not me. I didn't have to enter any credentials, so I'm just getting a client ID from this sample client. So if I take a look at the endpoint that's being called, you can see that that's located here under our DMZ server. Under our resource server, we've got this protected sample API. And enablement of OAuth 2 is really, really simple. So I've got this sample API, and all I needed to do to enable OAuth now was simply drop in on line 13 a require OAuth 2 encapsulated assertion. This is a reusable fragment. I can customize input parameters here, saying I'd like to customize this required scope, or this cache validation is going to be good for this long. But in this policy now, right, what's happening is I'm validating the OAuth token, and just as a stub response, I'm taking some of the validated information that's returned to the policy. So once I validate the OAuth token, I've got these session context variables, including the client ID, the scope, the expired at. All right, so that's what's returned in our test client here. All right, I'm going to clear this, and now let's do a slightly more advanced flow. All right, so now I'll do an authorization code grant type, and this requires a redirection. So when I initiate this handshake, what has happened is I've been sent to the authorized server. So this is the authorization code. This is the sample template that's rendered through our OAuth toolkit. I'll enter in the credentials here. I'll go ahead and log in. You'll see the grants. And now, similarly to before, I'm issuing an access token. Because I'm a confidential client, I'm following a different grant type. Now you'll see I've got my refresh token, which follows the spec. I can call the API with a new token. What you'll notice is that I no longer represent the OAuth 2 client, but rather my subscriber ID, or the authorized end user, is me, the end user, rather than the client application. All right. Now, if you had just installed your OAuth toolkit and you're trying to follow along with me through this example, this is going to fail for you. The reason for that is your redirect URL that would need to have the gateway from which your test client is executing was not populated in that schema information that was originally downloaded from support. So we have an interface that allows you to manage OAuth tokens and clients. This OAuth manager. All right, so we log in credentials here. This is the biggest, I guess, gotcha on initial registration and use of the OAuth 2 test client. So what you'll notice is I have a number of OAuth clients identified, but what you'll see in common is this test client 2.0 OAuth 2.0 client. This is the sample client that is this HTML browser page that's rendered from the gateway. So you can see under client auth code, what's coming back is an HTML page. That HTML page has an embedded client ID and client secret, which is found here under OAuth 2 client. So if I take a look at the keys for this particular client, you'll notice that I have under callback already added my server that I'm calling from, so gateway 2.10 on port 8443. So I had to come in here once this was populated, and right where it says gateway 2.10, it said your SSG, and I had to substitute my callback URL. Otherwise, authorization code grant type would fail, and you'd get an error saying the incorrect redirect URL was provided. All right, so those are your clients. You can also access the tokens that you can see here. So here's a couple of different tokens. We'll see the one that was just issued for me is right here, the admin token at OAuth 2 client, or the one that was issued to the token here that doesn't have a refresh token that follow the client ID, or excuse me, client secret, client credential, grant type. All right, the other one that we'll take a look at here is our SAML bearer. SAML bearer is a common extension that allows the exchange of a SAML assertion and the federation of the certificate that issues the SAML assertion to an OAuth token. This requires an additional little bit of setup as well, because what we're doing is we're requesting a SAML token in this case, and this SAML token is going to be issued by a certificate on the gateway, the default SSL certificate. All right. So now when the SAML token calls to the OAuth authorization server for an exchange handshake, the authorization server needs to be able to recognize that client certificate and say whether or not that's an authorized user to be issuing and signing the SAML assertion. Okay? So in order to enable SAML grant type, there is a SAML extension, which would be here. I'll get rid of some of these other screens. All right. So in order to enable SAML authentication, the default policy has a stop processing at line 7. All right. So in order to trust and validate the signing certificate that comes in the SAML authentication, I had to set up an identity provider, a federated identity provider. So you'll see the information here. I set it up as a SAML token federated identity provider. And whatever certificates were going to be used to issue the SAML token, I simply add them in trusted certificates. All right. So this might be any partner system, internal system, anything that's going to issue a SAML token that I want to trust. I'd add those certificates here. All right. You can also add additional certificate validations. And it's not the default request that you need to authenticate against, but rather there's a context variable called bearer token. All right. So those are 2 steps to enable SAML authentication. Create a federated identity provider with the certificate of the issuing authority or signing authority, and replace stop processing with authenticate against that newly created provider. All right. Once that is saved, we'll go back to our test client and the SAML grant type should start working. So now that I have my SAML assertion issued, shown here, I can click Initiate New OAuth Handshake, and I get a new access token that I can submit to my API. All right. And I can see under the grant type that this was a SAML bearer. All right. So that's how to enable SAML. All right. The last thing I want to take a look at is, we looked at token lifetime, we looked at SAML bearer, is how to exchange this UUID token for a JSON web token. All right. So back in our customizations endpoint, we'll click out of SAML authentication and we'll drop down to generate JWT OAuth token. This is again a hash policy. Now in this hash policy, the default template is already provided. If I can open this up. All right, so version 1 of 1 is shown here. And in order to switch from a UUID to a JWT, you simply have to uncomment the information. All right, so I'll save and activate that. Now everything is made available. And if I go back to my test client, and let's do a client credential. Hey, look at that. Now I've got a JSON web token that's been issued instead of a UUID. If I take my JSON web token, okay, I could copy this out and go into some type of JWT editor to validate it. You can see what's been issued. All right. Here we can see it's been issued, it's been signed by a very specific signer. So not my default SSL cert, but this JWT signer, custom signing certificate. We can also see the validation here. And there's this object in here entitled JTI. This is very, very important depending on how you'd like to validate the JSON web token. So bring this up quickly. So the difference between what we just saw, issuing a UUID versus a JSON web token, is the UUID is stored in the database and it's validated. I talked about that revocation checking before. When we select JSON web token access token, that UUID is still issued. That UUID is still sent to the OAuth database, and that still becomes a valid a token. The JSON web token simply wraps it. So when a valid JSON web token is detected, we validate the signature. That JTI value I just talked about is extracted, and that JTI value is the UUID, which is further validated. We check against the storage in the subsystem for revocation, and then access is granted. Now we realize that that's uncommon. Some of our customers have said, well, why do you do that? I just want to validate the JSON web token itself. And I mentioned earlier that you don't get the revocation checking, but it's possible. So in the configuration, there's a simple flag that says check authorization database, it's defaulted to true. So the flow on the left is what we get with the JSON Web Token default. What you get on the right is if you flip the flag and don't check the data, we will not do the OTK validation of that UUID. There's additional logic you can add into the validate JSON Web Token for additional claims and that kind of thing, but it really does become much more customized at that point. Okay? So that's the JSON Web Token. All right, I'm going to move on to OpenID Connect quickly, and I'll show, we've got about 10 minutes. I'm not going to drain this slide. The biggest benefit of OpenID Connect, not only can you issue symmetric, asymmetric ID tokens, but it really starts to bring in authentication of the end user on top of the validation of the user. It's JSON, very REST friendly. And for our implementation, we offer the whole JOSE capability, so JSON object signing and encryption. To create a customized signing key, there's a few customizations you have to make to those shown here. These particular capabilities, and I'll show one here. All right, so within our OpenID Connect JSON Web Key Set endpoint configuration, you can see where we create our JSON Web Key. And you'll notice here, by default, that would be set to your default SSL key. I've changed it to a JWT signer, which under certificates, manage private keys, is a customized private key that I've created specifically for this. If I wanted to change it from JWT signer to some other new certificate that I wanted to use, I could come in here and create, call it new signer. Want to click certificate will be used to sign other certs. All right, let me create it. All right, so now that that is generated and I've got that available here, I can simply come in and switch this to a different one or a new one. I could switch it to new signer, shown there. All right, there's a few other policies that need to be edited, actually only two, so let me show you those quickly. Completeness. Okay. Here's the first one. Well, we actually have two locations where you have to update that. Both here, under the signatures, change to JWS signer, or in the lower branch when you're signing the payload, JWT signer. Selected there. And finally, the validation of the token will be here. Okay. Now, what's beautiful, I think, about using the OpenID Connect endpoint and the JSON Web Key Set is the ability now to automatically do discovery and dynamic OpenID Connect registration. So we've got just a few minutes left, which is good because this demo will end very, very quickly. So in order to demonstrate OpenID Connect dynamic client registration, I have a SOAP UI test set up called dynamic OTK. So within this setting, as long as you have your OTK deployed, you'll simply need to add in your host, so that the server that's going to be hosting the OTK deployment, and then the resource owner password and credential. Right? So the end user to whom the OpenID Connect token or ID token is going to be issued. All right, those are the only three configurations that you would add in order to watch this work. Then we drop down in, everything's been automated as far as the tests go. We'll load up our test steps. And a sample will come up. There you go. All right, so we'll hit play at the top. Now what will happen is I'll generate a sample request to register the client ID. We go out, we hit the discovery endpoint, which returns information. Go down here and show what's been dropped out here. Yeah. There we go. Okay. So at the very top, we take a look at, we're generating the dynamic client registration request here. All right, we'll see the response that comes back. See, this is very standard for OpenID Connect client registration, and there's an additional scope that gets passed in here called OpenID Connect client registration. The path further goes down where we generate the authorization request, all right, which comes back here. There's an authentication step. Not that one, this one, where we get the response details. So here we can see the session is generated. We're going to then send the end user to the authorized consent capability. Here we can see the consent comes back from the end user's password. There's a authorization code transfer. We make the token request, where we actually retrieve our access token, which is a JSON web token in that case. And finally, we use that newly issued JSON web token to call the user info endpoint, which in this case returns the subject and the fact that I am Darth Vader in the response information. Now, what's interesting about that is we can go into the OAuth manager and do a refresh without having to go into this interface. Now I have a brand new registered client here. We can see the client scopes that have been issued. It was generated by admin user. All right, and we can likewise see the sample client here. Our demo app that was just generated and registered via OpenID Connect dynamic registration. All right. We have got not much time left for comments. Let me make sure I got through my slides, which I did. All right, so we don't have a lot of time for questions, 3 minutes. I can certainly address any that are thrown in the chat. Also, if you have questions that we don't get answered, I'll be sure to work with Bill and get back with any specific questions that you might have on how to implement OAuth or OpenID Connect in your gateway. With that, Bill,
great, thank you, Aric.
I'll turn it back to you.
Great, thank you. Real quickly before we move on to Q&A, I do want to remind everybody that next month's webinar is on May 20th, not the 27th, the normal last Wednesday, where we'll be again having Dmitry Sotnikov. With that, let me get the Q&A. We do have a few questions, one of which I know I'm going to butcher your name. I apologize. I think it's Sachin. I'm going to forward that to Aric and have him address that. There's no way we're going to get that answered in the period we have left. One of the questions is, will this be recorded? Yes, as I mentioned at the very beginning, we are recording the session. It will be available in about 4 to 5 hours on API Academy as part of a blog that's clearly labeled TechTalk, just like we've done for the last year. You refer to, Aric, some of your policies with a pound dash in front of it, so pound dash policies. Are these special,
yeah,
or is that just your convention? And in particular, do these overlay underlying policies?
Yeah. Yes, absolutely they do. So those hash policies or the pound policies, these are the ones that you're able to customize. So within here, these are read and write. So if I add any additional properties to this hash policy, all right, it will be picked up by the corresponding, in this case, OTK ID token configuration, right? So there's the hash policy that's shown here, but then there's an underlying policy for OTK ID configuration.
Let me switch the screen back to you because...
oh, I'm sorry. I thought I was showing.
Yeah, no worries.
Got it.
There you go.
Got it. I was just going to show that there is a hash policy that you're looking at here, the pound policy, that I would add any customizations to. That would be read or would be a child of the underlying read-only policy. So you can see one with the same name, but is missing the hash symbol in front of it. So this policy, without the hash, pays reference to and calls from and points to the hash policy. So any customizations you make would show up down here on 12.2, 12.3, and 12.4. So they'd be read into the parent policy, but you would only need to configure and manage the hash policy. Any changes in upgrades or functionality in the parent policy would just pick this up, and on subsequent upgrades, these hash policies are untouched. So any customizations you make will be carried forward into new versions of the OTK, while the parent policy, the foundational components that make up the feature might change. Your customizations will remain the same.
Great. The next question, this is answering Joe. We will let the product management team know that the docs are showing out of sync a little bit. And then the last question based on time, Shabazz wants to know whether we have to manually change the OTK token assertion from all of our services after an upgrade from 3.6 to 4.4.
The name should remain the same. So, for example, it should be OTK require OTK token. Maybe it's here. The name of the assertion that we use should not change. So if we take a look at, in this case, this protected resource that we looked at in the demo, OTK required 2.0 token. This name should be the same, and on subsequent upgrades, the name should remain the same, and so the policy will call the new version. It would only be the case if somehow this were altered and that the ID of the new policy didn't match the name of the ID of this one, that you would have a conflict. But with the architecture of our solution kit, newer versions should just replace right on top of it and be able to be called in the same existing policy with no change.
Great, thank you very much. And with that, we are going to have to call an end to our today's webinar. I want to thank Aric immensely for doing a great overview of OAuth and OpenID Connect. And I want to thank all of our listeners for taking time out of their busy day to sit down for an hour and listen to us discuss it. Thank you very much, and I hope you guys have a great rest of the week.